All right, so the first question we'll take a look at is adding two vectors visually. So there's no numbers, no values, no magnitudes, they're just two images. And how do we have to line up those two vectors if we want to add them? Let's call that one V and W, and let's do V plus W. How would we line them up?
Yeah. You take W and you can put it over V and put the bottom of W where the arrow is.
Yeah, so we're going to take the initial point of W, and we're going to line it up with the terminal point of V. Okay, so there's our visual. And now, how do we get the final answer, V plus W? Travis, how do we do that?
You make a line from the starting point of V to the end point of W.
Yep. So we're going to draw in that third side, and that's the visual for V plus W. Okay. Any question on adding two vectors together visually? Okay. So next question we'll take a look at is finding a position vector. So they've given us 2 points. In this case, P1 is the initial and P2 is the terminal. What would be the calculation to find the x component of the position vector? What do we have to do? Savannah, do you remember what we have to do?
Find the position vector.
Yeah.
Is it multiply 3 and 5 and then -74? Is that a different thing? That's
that's-
something, but if it's, I think it's a different thing.
That's a
isn't it?
dot product. yeah.
Okay. No, that's the one I remember.
All right. How about Alexa? Do you remember?
Would you do 3 minus 5?
Yep.
And then -7 minus 1?
And -7
Oh,
minus.
so low key, I got the numbers right. Just not the same.
And when we simplify 3 minus 5, Travis gives us how much?
-2.
-2. And -7 minus 4?
-11.
-11. So that's the position vector written in that notation. How could we also write the position vector in unit vector notation? What would that look like?
-2i
Yep.
minus 11j.
Minus 11j. Okay, so those are the two different ways that you could write the position vector. All right, so for the next problem, we're being given two vectors, and they want us to do 3 things: add them, scale one of them, and find the magnitude. Let's start with the sum, okay, V plus W. So not a visual, we're just going to do it with the numbers. Well, Eileen, what would be the horizontal component when I add V and W together? So what's the horizontal component of V?
5i.
And the horizontal component of W?
-3i.
And then we add them together.
2i.
2i. So when you add them together, we get 2i. And Alexis, what's going to be the vertical component when we add V and W together?
-2j. So like -2j.
So what's the vertical component of V?
Is it -4 and 6?
And yeah, for W it's 6, so when you add those together,
-2. No, +2.
positive
Okay, stop.
2j. So 2i plus 2j. All right, and Savannah, how would I find 3v?
It's a real great question.
Do you multiply like each one individually?
Yep, multiply each component by 3.
So is that 6i plus 6j? Or is it, all right, so do you do it for the top?
Well, we're doing vector v.
Okay, so that would be 15i minus 12j.
15i minus 12j. Yep. And the last one is finding the magnitude of w. Travis, how would I find the magnitude of W?
Is it the square root of -3 squared plus 6 squared?
Yep. So square root of -3 squared plus 6 squared. And what's -3 squared?
9.
9. And 6 squared?
36.
36. And that gives us a magnitude of square root 45. Okay, if they wanted us to reduce it, we could break that up into 9 times 5, which would be 3 square roots of 5. Okay, we should always be able to reduce the square root just in case they ask for that on the test. Okay, so any questions on adding, scaling, or finding magnitude? Okay, so next question we're going to take a look at is finding a unit vector for a given vector. So what does it mean if a vector is a unit vector?
It's 1 unit long.
It's 1 unit long. So the first thing we have to do to figure out how we need to scale this is we need to know how long this vector is. What do we call that when we find the length of a vector? It's the what of the vector? Yeah, the magnitude. So, Alexis, can you tell me how I'd find the magnitude of V for this one? So look back at the last problem we just did with magnitude and kind of do the same thing we did there.
Okay. So square root -5 to the power of 2 plus 13 to the power of 2.
Okay, so we'll do that now. Savannah, what's -5 squared?
25.
25. And Travis, 13 squared? Oh, you know what? This number is not going to come out to a nice value, but that's okay.
It's 13 squared.
You can use a calculator.
Yep, and 69. Okay.
He doesn't. I know.
So add them up, and what's 25 plus 169 give us?
194.
194. So right now, our vector has a length of the square root of 194, which definitely is not 1. So what do we have to scale the vector by to make the length 1? Yep.
1 over the square root of 194.
Yeah, it's going to be 1 over the square root of 194. Okay, so we're going to multiply that out to each component, and that'll make it have a length of 1. So we're going to get -5 over 194i plus 13 over 194j. Now, I'm going to see if I can clean up the square root of 194 a little bit. So if we check, let's see, 194 divided by 4. So that doesn't go into it. I'm just checking if there's any perfect squares. 9 wouldn't. I don't think 16 would. 25 won't. 36. No, that's not going to go into it. 49, I don't think that's going to work. I don't know if there's any perfect square that goes into it. So 49, 64, no, 64 is not going to go into that. 81, well, 81 goes into once, no, that's not going to work either. 100 doesn't work. So no, I don't think there's any perfect squares that go into it. So the only thing we could do is multiply top and bottom by square root 194. negative 5 root 194 over 194 plus 13 194 over 194j. So not a very clean answer, but that's the concept. That's what's important. You multiply by the reciprocal of the magnitude to turn it into a unit vector. Okay, so next problem is asking us to do a couple things. First, they want us to find the dot product, and then we're going to use that to help us find the angle. Okay, so let's do the dot product. All right, so V is 4i minus 8j, and W is 3i plus 5j. Savannah, what's the dot product here?
So what did you do? 4 times 3.
Yep.
And then plus negative 8 times 5.
Negative 8 times 5. So it's going to give us 12 minus 40. And 12 minus 40 is going to give us negative 20 what?
Is it 28?
Negative 28. Okay, so we've got the dot product. Now, they want us to find the angle. What's the formula for the angle between two vectors? Anybody remember? How about Travis, do you remember what that formula is?
V dot W over the magnitude of V times the magnitude of W.
Anything else?
Is the angle.
So that doesn't equal the angle.
Oh, cosine theta.
That equals the cosine of the angle. Yep. All right, so we've got the dot product. We need the magnitude of V and the magnitude of W. And the V and the W are just two letters I choose. You don't have to name everything V and W. You can use different letters. Don't use I, J, or K, but you can use other letters. Alexis, how would I find the magnitude of V?
You do the square root of 3.
V.
Yes.
So the 3 and the 5, that's in a different vector. So we're not going to do anything with W right now.
So 4
4
squared.
squared.
And then would you do plus negative 8 squared?
Plus negative 8 squared. Yep. And that's going to give us 16 plus 64, which, how much is 16 plus 64?
Okay, how about
80. So that's the magnitude. Now that I could reduce. I'm not worried about reducing it because it's not a final answer to a problem. It's something I'm going to plug into a formula. So we got the magnitude of V. And how about, Travis, what's the magnitude of W?
square root of 3 squared plus 5 squared?
Square root of 3 squared. 3 squared plus 5 squared, which is the square root of
Alright, so 34.
34. Yep. Okay, fill it all in now. Cosine theta equals the dot product over the product of the magnitudes. Dot product was negative 28. And the product of the magnitudes is square root of 80, square root of 34. Okay, and Eileen, how do I solve for theta? Inverse cosine. Okay, and I've got a product in the bottom, so I need to make sure that the denominator is in parentheses. So negative 28 divided by square root of, if you want, you could actually just do it like this. It's kind of a shortcut. You can put both square roots together, and then if you do it that way, you don't need parentheses. I didn't show that in class, but just the property of combining two square roots. That gives us an angle of 122.47 degrees. Okay, so now my next question is, are those two vectors parallel, orthogonal, or neither? Yeah, this is neither. Okay, the reason it's neither is because to be parallel, what do you have to get an angle of if two vectors are parallel? Yep.
0.
Or
180.
180. And what do you get for an angle if two vectors are orthogonal? Savannah, what do you get if two vectors are orthogonal for an angle?
I want to say 0, but I don't think it's 0.
0 is parallel.
Oh, okay.
Yeah. What does orthogonal mean? Yep.
90 degrees.
Yeah, it means perpendicular, which
Oh.
means 90 degrees. Yeah. So this angle's 122. That's neither. Let's look at finding a three-dimensional distance. So we're looking at two 3D points, and we want to find the distance between them. Okay. What's the first thing I should write down anytime I'm finding a distance? This is a big part of the formula.
The square root.
Right, we're going to have a square root. Okay. And Travis, what's going to be the first calculation under my square root?
X2 minus x1, so it would be 3 minus 4 squared.
3 minus 4 squared. Yep. And Alexis, the next calculation under the root?
It would be -7 plus, in parentheses, -2 squared.
So that's going to be -7, and what did you say comes after it?
Oh, minus,
Minus.
and then in parentheses, -2.
Yep. And then we square it.
Yeah.
And then Savannah, the last one?
Is it 8 minus 5 squared?
8 minus 5 squared. All right, so let's do that up and see what we get. So we're going to have 3 minus 4 gives us -1 squared. What's -7 minus -2 squared?
-11. No, I could have done that wrong.
Would it be -5?
Oh, my bad. I didn't see that. I just said parentheses.
-5, and then when you square it,
25.
25. And 8 minus 5, that gives us 3 squared is 9. And that's going to give us the square root of 35. So that's how you find the distance between 2 points that are 3D coordinates. Okay, any questions on that? Okay, so the last problem we're going to take a look at is finding the cross product between these two vectors. Okay, the way that we do it is we use Sarris's rule, which tells us we're going to make a table to kind of organize everything. What's going to go in the top row of our table that we make? Just the first 3 columns. Yep.
IJK.
IJK. Good. What's going to go in the middle row? Travis.
2, 4, -1.
2, 4, -1, and I mean the third row.
16, -5, 3.
16, -5, 3. Okay, and now we've created the 3 by 3 table. What do we have to do before we start looking at the diagonals? Yep.
Add an I and a J.
Yeah, so what are you doing in general, like for all of it?
You move the first 2 columns next to the K.
Yep, copy. So we're going to keep them where they are, and then we're going to create a copy of them next to K. So IJ, 2, 4, 16, negative 5. And now, what do we have to look at in that table? We have to look at all 6, what? Yep.
Little groups.
And those groups are, how are they arranged? Like, how do we find them? They're the 6. Travis, do you remember?
Like the diagonal.
Diagonals, yep. So we start with the ones that go down and to the right. So we have I times 4 times 3. Alexis, what's I times 4 times 3?
12I.
Yep. So we're going to just write out our template that we're going to fill everything into. So the first one we fill in 12I. Travis, what do I fill in for the next one?
Negative 16J.
Negative 16J. Yep. And the third one, I think?
K to negative 5.
Yep. And what would that be?
K negative 10.
So negative 10K.
Oh, sorry.
Okay, and now the other ones, these are all going to be subtracted. Alexis, what's our first diagonal that goes down and to the left?
K 4, 16.
Yep. And what does that multiply to?
64K.
So 64K. And Travis, the next one.
Minus 5I. So it's
And how did you get that?
negative 5, negative 1I.
And what do those multiply to?
5I.
5I. Yep. So 5I, and that'll be subtracted. And Eileen, the last term we have to fill in?
6J.
Yep. J times 2 times 3, which is 6J. Okay. So now we've done all the calculations we have to do with that table. So what is there left to do now? Yes.
Add them or subtract them.
In what way? Just add them all together?
Like the like term.
The like terms. Yep. So we'll do the like terms. Let's start with the i's. Alexis, what's 12i minus 5i?
7I.
So 7i. And Travis, negative 16j minus 6j,
Negative 22J.
negative 22j. And Eileen, negative 10k minus 64k.
Negative 74K.
Yep, negative 74k. And that's the cross product between vectors v and w. Okay, any question on finding the cross product?